Okay, so what we're doing for this section is we're solving simple equations. The learning target is to understand what inverses to perform first and also what inverses is needed for each step. So first of all, we just need to know what an equation is. Let me see if I can find my highlighter. Okay, so an equation is an algebraic expression with an equal sign. When working with equations, it's important to think of them as scales because we need to keep them balanced. So if I had a scale here, right, and I have this platform here and this platform here, I'm going to have to do something to both sides of these scales so that it stays even. It's kind of like a teeter-totter. If you get off, then the other person's going to go flying up, and we don't want that. So we need to keep this scale balanced. Okay, so we're going to model this with what a scale looks like. So on a scale, you're going to have like two things, right? And it's supposed to stay balanced. Sorry, my scale's a little crooked. And so right now, I have an x plus 3 and 5. Well, in order to be balanced, they both have to be 5. So what number plus 3 gives me 5? That's right, it's 2. So I know that x has to be 2 plus 3 is 5. And so I have 5 on both sides. So that's how I kept it balanced. Okay, so let's look at this next one. Same idea. I got my scale. Ooh, that one's straighter. And I have a 2x, which is saying 2 times x, and a negative 14. Well, the only way I can have these balanced is 2 times something gives me negative 14. And yeah, you're right, it's 2 times negative 7. So that would give me negative 14 and negative 14. So that balances it. And on the last one, same idea. I got my scale. And it's x minus 7 and 10. Well, what number minus 7 gives me 10? Yeah, 17. And so this is 17 minus 7, which is 10. And this is also 10. So some of you, I'm sure, are going to do really good and understand automatically what numbers are. But there's going to be problems that are fractions or decimals. And so you really have to understand the process. So while we have things scaled off and they're balanced on both sides, you still need to know how to solve them by doing what we call inverse operations. So to solve equations, you have to do the inverse operation. So the inverse operation of addition is subtraction. So what that looks like is I draw my line down. That's like the center of my balance. To get rid of a plus 5, I do the opposite of plussing 5, which is minus 5. So I'm minus 5 on both sides, and I get 3. Over here, it's the same idea. Even though x is on the other side, I have to get rid of a positive 3. To get rid of a positive 3, I subtract 3, and so I get 7 as x. Now, if addition and subtraction are opposite over here, they're also opposite over here. They're the inverse of each other. And so, again, I put my balance beam down, and this is a minus 5 or a negative 5, and the opposite of a negative 5 is a positive 5. And one thing I didn't talk about a lot, but remember I'm keeping it balanced. If I add an extra 5 to one side, my balance beam is going to go up. So I have to keep it balanced by doing it to the other side also. And so I get 3. And then one more here, even though it's on the other side, it's still a negative 4. And the opposite of a negative 4 is a positive 4. So I add 4 to both sides, and so I get 11. All right, now we have the next two operations. Multiplication, the opposite of multiplying is dividing. Oops, division. There we go. So this says 3 times x. So I do not write a divide by sign. What I do is I treat them like fractions. A lot of people don't like fractions, but the more you do them, the more comfortable you are with them. And so now 12 divided by 3 is 4. Same thing on this next one. I have to get rid of a times -5, so I'm going to divide both sides by -5. And then -15 divided by -5 is a +3, because remember I can circle them. Okay, well, if division is the inverse of multiplication, that means that for division, the inverse is multiplication. So division, again, is usually going to be written as a fraction. It's very rare you're going to get that little divide by sign that looks like this. You're in high school now or you're doing Algebra 1, that does not usually happen anymore. So to get rid of a divide by -4, I times both sides by -4. Well, my goal on the left was to cross him off to get rid of him, so that's what I'm doing. And now x is equal to -20. Same thing here. I got to get rid of this divide by 2. So to get rid of a divide by 2, I multiply both sides by 2. 2 times -6 is -12. And those 2's crossed off. All right, so how do you check your solution? To check your solution, you plug it back in. Plug in. If it is true, you did it right. So what I'll do is I will do this problem right here. So we found for 3x equals 12, we found that x was 4. Well, I take this x and I plug it in here. So it becomes 3 times 4 equals 12. Well, 12 equals 12. So we did it right, so that is the answer. If you're ever not sure if you got it right, plugging it in and checking is a great thing to do. All right, now what I would like you guys to do, because I gave you 4 examples up here, actually 8 examples, I'd like you to try these on your own. When you think you have it, press play, and then you can check your work. If you do 1 or 2, and then you want to come back and watch the others, just keep pressing pause whenever you need to. Okay, so I draw my line down. I need to get rid of a -4, so you should add 4. -4 plus 4 is gone, because it's just 0, and 8 plus 4 is 12. All right, here I have 2 negatives, right? And they're next to each other. So the way that I teach this is when 2 negatives are next to each other, I circle them and it becomes plus. Now I do tell some people to write it over again because then it's not as confusing, because I don't see any negatives now, I just see a plus. And the way you get rid of a +2 is by minusing 2. So x is -5. For number 3, I have x over 5, and over just means divide. So I need to get rid of a divide by 5 by multiplying by 5 on both sides. 5 divided by 5 is gone. It's just 1, so it's x. And -2 times 5 is -10. All right, now sometimes x is going to be on the other side. Don't worry about it. You still just do the same thing. I need to get rid of a +4, so I'm going to -4 on both sides. And I get -19 is equal to x. All right, and then number 5, this is 3 times x. So you're going to divide both sides by 3. So I get -9 as x. And then last one, here's an example of when you see that divide by sign. You don't actually see it that often, but I wanted to get you one so you can see what it looks like. Whenever I get that, I automatically just switch it to a fraction divide. And now to get rid of a divide by -2, I multiply by -2. And those -2's are gone, so I'm left with a +24 is equal to x. And that's it. So you have to remember what is the inverse for each thing, and then you have to remember to do it to both sides. Make sure you do that inverse operation to both sides because you got to keep your scale balanced.